for stereo and singles for mono.
Yeah, absolutely. Those little rings that you see if I can you guys see this?
Yeah.
Hmm.
Rings there, right? See that? Can everyone see that? Yeah?
No, yeah,
It's
yeah.
a bit out of focus, but yeah, there's two rings there. If you look at a jack lead,
I want to say, do you want one for reference?
yeah, I was gonna
Yeah, single.
one ring, right? Because obviously guitar signal is mono, and that cable that I'm using to is connected to my headphone amplifier, which is I want stereo signal because it's for my headphones.
So why do
But
most like guitars like Nigel's got use unbalanced cables then instead of a stereo one?
because where would the stereo signal come from in a guitar?
Yeah, it wouldn't because it's yeah,
That's why
yeah,
it's one instrument.
yeah,
There's no left or right.
yeah,
It's just
yeah, yeah,
straight signal.
yeah,
And then the panoramics are created then in the on the mixer. But
yeah,
um, yeah, it's one instrument. That's why. And it's very simple to understand. Like it's simplifying our thinking is really important. Like I said at the beginning, right? Straight lines. I've always been a bit of a pragmatic person, but trust me, stage life taught me pragmatism on steroids. Because if you start messing about with cables and processors and this and that, I'm gonna put this effects box on here. Before you know it, suddenly like one of them. Here's what happens. This is real life. One of the monitors start going shh, and you're like, oh, now I have a million cables to go through. But you need to learn to be pragmatic. You gotta go like, okay, what's most likely? And I've shared this philosophy with many of you guys, right? If there's anything that breaks down, start by replacing or fixing or whatever the cheapest thing in your sequence. Don't go on Amazon and buy a new speaker when maybe it was the adapter connected to the cable, which costs 50p, right? You see what I'm saying? Like, so always be pragmatic like that as well. The cheapest thing first, and then okay, that didn't work. Try the next cheaper thing, the next cheapest thing, the next cheapest thing until okay, if you need to replace the speaker, then you replace the speaker. Um, so um, balanced and unbalanced. Back to our mixer. And then we've got an insert. And now another terminology question. Does anyone know what that I/O means?
Um, few things. It's either on, off, or input, output.
Okay,
I guess.
that's a good guess. Anyone else wants to jump in? So input output is absolutely correct. Okay. Now, what are these for? These are for you guys to plug. Say, for example, Nigel has got a great example. This might sound. You might have a guitar rig, like a processor for your overall sound on your rig. You got your pedals and this and that, and then you might have a little rig, which many guitarists have. You would plug that into your insert input output input in this case, um, and because it's a pre-fader and pre-fader means before you alter the volume, right? The fader,
Hmm.
for those who don't know, is this. That's a fader, sliding fader. That's what that's called. Okay, so that's a pre-fader input. So it's completely unaffected by it, and it's going to be controlled differently. We might not be able to get into all those details today, but like I said, this is the same mixer I have here at the Academy, so next week you guys will be able to actually see it. I've lost my thing. Okay. All right, so now here we are. Knobs. All sorts of knobs for us to mess about with and see what they do. The very first one, the white one, for the man who has experience with mixers, that would be Derek. What is that?
It's called a gain button, but it's not to be confused with a volume button.
It's not to be confused because it's not one. So if you confuse the game button with the volume, which is there's no volume
The reason
button.
I say with that is people turn the gain up really high, thinking it's a volume button, and then it.
Very good. Okay, so you're already okay. So since you made that distinction, I'm gonna once again play along. Why is that not a volume button? What's the difference? What's the difference between the gain button and the fader, right? Which is our volume. There's no volume button. There's a fader, right?
Oh, got right. Doesn't the gain button basically give you more power to the circuit?
Yes, exactly. Right, exactly. It increases the amount of signal.
It basically makes it more sensitive, doesn't it? But that's where you get the feedback from.
Define sensitive. You can get feedback from the fader as well. We can get into feedback as well as to why that happens and all that. But you already nailed it. It increases the intensity of the signal.
Yeah.
Absolutely. Whilst the fader, the slider, merely increases the output of that same signal, not the intensity of the signal. So the gain. So let me say it differently, right? The gain increases the signal that is coming into. Let me see. Let me rephrase that. The gain button or knob increases the input signal, whilst the fader increases the output signal.
Yeah.
Does that make sense for
Yeah.
everyone? Right? The
Yeah.
gain increases the intensity of the signal that's coming from the microphone, whilst the fader increases the signal that's going into the speakers.
Yeah.
Okay, which is very different.
But that's where you get, obviously, if you turn the gain up too high and the fader up too high, you get like, you end up getting a clash, and that's where you start to get feedback loops, isn't it?
Let's talk about feedback. Yes, that's one. That's a bulletproof way to get feedback. What you described. Why do we get feedback? Because, by the way, it's not for recording. It's not really relevant. We're not going to get feedback. It's not the kind of environment where feedback occurs. That's more stage. But Nigel, for example, being a guitarist, can and should know how to work with feedback to create to create sound.
Yep.
To create a texture, right?
Yeah, yeah.
You hit that note and then you feed it back into the amp. I already gave a bit of the answer as to why feedback occurs, right? Why does that happen? Let's think microphone instead of guitar makes it easier. Why do we get feedback? What's that phenomenon? We've all heard, by the way, have you all noticed that in every single movie, TV show scene, when someone uses a microphone, as soon as they approach it, feedback happens?
Mm.
Have you ever noticed that, right? There's all scenes, like rom-com movies, there's always
Yep.
that drunk scene at the wedding. I just went, wee! Like, that's not a thing. That's not a thing. You don't get feedback from grabbing a microphone. It's like they need to give us, the dumb audience, the signal, hey, this is a microphone.
Mm.
Like, what? That's not, look, no feedback. Always, like, it's one
Is
of
it
those
from
things
like
where-
too much going into the microphone?
Yes, but why do we get that sound?
It's where like frequency of a microphone or instrument is picked up by something else and then amplified, and then
Something else?
like a stage monitor or something like that. It's picked up.
Okay. Well, stay careful there, because stage monitors don't pick up; they put out.
Just another microphone.
So he basically picks up the signal of, say, like a microphone or whatever, and then amplifies it, and then actually puts it out.
Wait, so wait. Remember the term, right? It's feedback.
Mm.
Feedback. So you got microphone. Okay, we only need two things to get feedback, right? Microphone, speaker. So this is a very simple A to B problem, right? So you've got microphone, speaker. Signal goes into the microphone, comes out of the speaker. Why do I get feedback?
Because there's a signal from the speakers going back into the microphone.
Exactly. What's coming out of the speaker is so loud that comes back into the microphone, back into the speaker, back into the microphone, back into the speaker, back into the microphone, back into the speaker.
Right.
Oh, that's what you call a feedback loop, then. Ah, right.
Yeah.
Right.
You accumulate all those frequencies simultaneously, because now you're having like in out happening simultaneously in real time, overlapping. The accumulation of frequencies will always be a spiral of sound upwards. That's why it ends up. It usually starts with. You can hear it at the beginning. It's got a bit more of a throbbing sound at first. It's not straight away like plugging the speaker, and hit the high note. It's woot. You can hear the escalation. If it's really loud, it's going to happen very fast. It's also got to do, obviously, for the reasons that Dan already said. If the speaker is closer to the mic, it happens even faster. If it's farther away, you're going to get more of a boom, 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 more progression. It takes longer to go from speaker back to the mic, speaker, mic, speaker, mic. Pretty cool, right? Physics.
That explains why they stick microphones against amps, and when amps are finished.
Huh? What did you say? I only heard the first half of your sentence.
You've
That's
seen it.
the opposite of feedback. What happened there?
Oh,
What did you say? That's what happens. Microphones and what?
so when they stick guitars against the blooming guitar amps, you know, at the end of gigs and stuff.
There's no need to be snarky against guitar amps, but let's talk about that, because I was kind of poking at that earlier, right? Why do that, and why do you get feedback, Nigel, when you do that? Now that
Well, it's the same as before. You know, you've got a microphone and you've got a speaker. Only in this instance, your microphone's your pickup and the speaker's your guitar amp. And it's kicking out sound. It's probably amplified even more by the fact that it's probably vibrating the strings as well, which is then causing more action on the pickups, which is putting out more and then making it vibrate, and it goes round and round and round.
Now, the beautiful thing about that is because it's such a controlled environment, because it's really close, isn't it? Because the pickup is a very sensitive microphone of very low signal.
Yep.
Right? That's why, like, if you're speaking close to a pickup, it's not going to pick up your voice. But if you get real close to it, right, it actually reacts to it.
Yeah.
You need to really put your mouth on it.
Oh, yeah. It's like you can hold your phone up to it and it'll
Absolutely.
play through the pickup.
Yeah, but it's very low signal in general. Now it's got high impedance, which is why then you get big output. But that's okay. That's a different, because then humbuckers have different impedance levels and this and that.
Yeah.
But the reason why it's so cool to use it in the guitar context is because, unlike with the microphone, when you're gonna get all sorts of inharmonics and dissonances and this and that, so the feedback sound is really ugly. Most people react to it like, turn that off. When it comes from a guitar, when you're holding a note, it's not like it sounds good, because actually what you're creating, I forget the exact term now. So forgive me, because I've forgotten the term in physics for this, but it's because frequencies work in like if you produce a frequency say a central frequency of 440 hertz, yeah, A, central A on the piano, right? The reason why you get an understanding of timbre and kind of sound you can differentiate from a piano to a guitar playing an A, it's got to do with the harmonics. But if you analyze the waveform of any frequency, any musical note, from an instrument that is in tune, by the way, if it's out of tune, you're going to lose this effect, which is why tuning is so important. The frequencies always double up. So the harmonics of an A, which central frequency is 440, is then 880, and you know, and whatever the next 17 and 60, and so on and so forth. Right? Did I get that right?
Yeah, it's too late to do math.
Yeah, that's right. Yeah.
Laptop's
Right.
closed for today.
And so on and so forth, always doubling it up. So that's why when you get close to a guitar amp, the feedback you get from it is in the same note of the note you were holding.
Is it overtones? Is that what they call that?
Yeah.
Yeah.
Yeah, but it's harmonics, right? That's
Yeah.
I think overtones. I don't want to say. I have a feeling that overtones might be the frequencies that happen outside of that exponential effect.
Okay.
Yeah,
Yeah,
but
I'm
I
not
might
sure.
be wrong. I might be wrong.
Either way, it's a good effect. And
Yeah.
it
So
can be,
right, because it but it
very
only works
useful.
because it's so close to the source. If you start to get all the noise in there, then the feedback effect that you get is much more noisy and not musical, because it starts to get all the frequencies into the mix. And here's another nerdy question. This session is going much faster than I thought. We haven't even talked about the auxiliaries. I honestly thought before today, like maybe like just talking about the mixer is not going to be enough today. Right. Uh,
3 parts down.
I know. Typical, right? Anyway, here's another interesting question. We've all heard, I'm assuming, the expression white noise and static. Does anyone know where that comes from? Like not the term, the actual phenomena.
I do, but I don't want to spoil it.
You do, okay? You
Yeah.
can hold it. What creates white noise?
Clue.
Ah?
Not a clue. It'd be a load of rubbish if I tried to.
Not a clue is a good answer. That's
I only know because I've looked it up.
well, that's not knowing. That's Google knowing. I know it. Yeah, I know. And Nigel said I know it without looking anywhere, so he knows it. Because
Yeah.
nowadays, 21st century, there's two kinds of knowing, right?
Yeah.
You know it, or you Google know it. How about you, Ben? Are you like no clue? So you got
Nah, I don't
two
know.
no clues, two knows it, and one Google knows it. Right? Just because you openly cheated, I guess, because you did say that you cheated. Do you want to give us the answer that Google gave you?
I've turned it off now.
But do you have an answer or no?
See what it says. Might be wrong.
If it's on Google, it's unlikely.
One of them says, in signal processing, white noise is a random signal having equal intensity at different frequencies, giving it a constant power spectral density.
Right. Now in English,
I have no idea.
that's the advantage of knowing, because now we can give you the translation. I'll give you a super simple, and then Nigel, you can tell me if this is what you knew about it, or if you know something else that you want to add to it. But white noise is the much like the color black, the accumulation of all frequencies creates that noise.
Right.
Right. In fact, I apologize. I said the color black. The color white is the sum of all colors, right? Hence the term white noise. It's already on the tin. There's other kinds of noise. There's pink noise as well, which is it's got a different. It's not the sum of all frequencies. I believe it's the sum of all positive amplitude frequencies, something like that. I actually forget the exact term for that one. I might need to Google know that one eventually. But yeah, so white noise is the accumulation of all frequencies in the spectrum. So even if you run, I forget what the actual term is. Sinusoidal frequency study. So that's when you run from the lowest frequency that whatever emitter can produce to the highest, and then you add also speed to that. So so you would go like comes back down. The next time it will be faster, and faster. Eventually becomes because it's so fast that it just blends in. It becomes white noise. It's super interesting to see that happening from a machine that is analog. It's in front of you, and you're literally dialing up the speed. So it's physically you're controlling, turning that into a very slow build into static. And literally, you know, it was you doing that. It's super interesting. I was very lucky to have access to all sorts of fancy machines back when I was studying this stuff. Okay, so 10 minutes. Let's go. Few more bits. Okay, these mixers also have a bit of a compressor. This compressor, to be honest with you guys, I don't want to get too deep into this because compressing and compressors is a bit of a science. And this one button on the on this mixer, it doesn't really make justice to what compressing is. So in a very, very quick nutshell, compressing is reducing the distance between the lowest, not the lowest, but the weakest signal in the waveform and the strongest peak of signal in the waveform. So you reduce that distance by flattening the wave a bit. So you bring the quietest sounds up a notch and you bring the loudest sounds down a notch. That's what compressing does. Okay, then it can be used in very creative ways and much more interesting ways than just that I just said, but I don't want to get too deep into that right now because otherwise we won't even be able to get it in 10 minutes. EQ. EQ, very important skill to have. Solves a lot of problems, including feedback problems, which we talked about, because there might be just one frequency or a group of frequencies that's standing out too much, and EQ can solve that without you having to lower the signal. So this is quite important for you guys to know, right? There might be a frequency that is resonating from the actual instrument, like a snare drum that's a bit too ringy. So actually the harmonics of the ringiness is causing the feedback rather than the volume overall of the snare. Does that make sense? In fact, you can get acoustic feedback. I don't know if you guys ever realized this, like if you ever clapped in any like room in your house and you heard a bit of a springy noise coming back to you. Has this ever happened to you guys?
Oh yeah, yeah.
Right, so that's feedback in real life, in the real world, in nature. There's a corner, usually it's a corner, like between the ceiling and the walls, right? Where that frequency sympathetically resonated with the walls. So you clap and it vibrates, it resonates away from you, goes against the walls, and it finds a little sweet spot there where the distance between those two walls, literally the physical distance, matches the length of the wave. So then it starts bouncing because it feeds itself. Of course, eventually it dies out, but that's the springiness, is that then it dies. Because it's literally, it's a bouncing ball. Right? It's very super, super interesting stuff. It's so funny because we never see sound as something physical, do we? Like, we never see the fact that, I don't know if any of you guys, I think I'm going to close with this story, actually, instead of getting into EQ. Have you ever been in, here comes a very highbrow word. Anechoic chamber.
I don't know.
Couldn't tell you.
Anechoic. You would remember it because it's quite an experience. So you would remember the name actually. So that I think there's only, well, I know for sure there's only a few in the world actually of these, and there's only like 3 or 4 in Europe. I think there's like maybe 1 in the UK. I know there's 1 in Lisbon. That's where I went. So this is a very special room. So an anechoic chamber is a room designed to have no reverberation, no echo, nothing. So the structure of it is quite extraordinary, like architecturally speaking. I'll show you guys a picture. But the principle of it is that in that so anechoic stands for Latin stands from lack of, coic stands for echo. So let me show you what these crazy rooms look like. It's absolutely outstanding. This one is very similar to the one I went to. Look at this. Can you guys see that?
Yeah.
Oh, yeah. I think I've seen these.
Okay, so these are extraordinary places because as you can see there's no floor per se, right? And there's no perception of depth. In fact, this one is very organized. Many anechoic chambers, the structures are much more random, and that's on purpose. Now this one is not great because there's a floor. Okay, the one that I went to had no floor, so you would walk on a net. Okay, you would have they had a metal net to provide, you know, like some sort of walking surface, but obviously it was a net. So, and then below us was those kind of like strange shapes and stuff, because that's the idea is that the randomness is purposeful because it kills the sound from bouncing. There's no chance it's gonna find any kind of like friendly corner, right? Everything is gonna cut angles and boom, and absorbs the sound. Now, why am I bringing this up? I said like you clap in a division of your room, you get that the rebound, and I said we never see sound as a physical phenomenon. And these chambers are a wake-up call to the importance of the environment for sound transmission. Because, for example, if we're talking to each other in real life, the fact that you can hear me has to do with a couple of simple things. There's air in between us, which carries the frequencies that I'm emitting from my vocal cords. Cool. There's also the walls creating amplification via reverberation, right? So you can hear me better without me having to put out more volume, because the room is helping. It's creating that natural amplification. In an anechoic chamber, you can't hear your own voice. And that's when you realize what is going on. You can hear it inside of you, right? It resonates in your skull, but you can tell that it's not going anywhere because the air is very stale in there. But first of all, on purpose, they do air pressure control, this and that. So it's very like stagnated air. There's no windows. They close the doors, like thick doors, and there's no walls. There's no ground, there's no floor, there's no ceiling, so to speak, right? At least plain surfaces. So then if you're there with 2 people, if you turn your back, if you're facing each other, yes, you can still hear each other. But if you turn your back, it sounds like the other person is like a mile away. You can hear them, but it's like, can you hear me? And you're touching backs.
Jesus.
If you then go go against one of the walls and speak into it, then it's really bonkers because your voice just doesn't go anywhere, disappears completely. So your perception of space and everything, lots of people end up like being sick in rooms like those, like they literally throw up. because their perception of space and depth goes out the window. And this, we don't even know how much. We know that our ears play a massive role in equilibrium and balance, right? So then your ears are not doing any work. They don't know what's up and down, what's left or right, because sound is not coming back to feed that information. Right? It's super, super interesting. Yeah, go on.
Yeah.
Nigel.
No,
yeah.
just saying it'd be good to give it a visit, but they're few and far between. I know
They're
there's a
very
few-
rare and usually at physics departments.
Yeah, not open door policies then.
No, no. I mean, we could. I don't know where the nearest one could be. I could see.
One-
If I could.
One
push
of
it.
unis would have one, wouldn't they?
Yeah, but they are very rare because they are extremely expensive to build, and most unis don't see the point in building one of them because it's so niche, right? They're very expensive to build for almost nothing. They study the effects of like sound and like speakers and mics and this and that, but it's so neat. It's the study of sound is so limited, especially in such a controlled environment. It's interesting, but like, would you spend millions if you were a unit to do that?
Oh, is that how much it is?
They're very expensive to build. Yeah,
Jesus.
it's the architecture that is extremely expensive because if you do like one of the angles is wrong, it's already not an anechoic chamber, and then you might as well bin it.
Right.
But the other thing that is also interesting, and to close with that, when I was, because one of the things that the guy who was running that tour that we did when we visited that chamber, because it wasn't at the school I was going, so this was a trip we took there when I was studying sound engineering, and then we went in there in pairs, and then he invited like 5 of us to like, okay, just go in there by yourself. And I immediately, because I'm always like, come on, I'm game, let's go. It's so bizarre what happens to your hearing, because your ears start to feel the discomfort, and your body starts to react to it. Your body starts to feel a bit like, where are we? Like,
That's
what is
like
this
ver-
environment?
Yeah, that's like vertigo.
No, vertigo is already a consequence, but your body at this vertigo can happen, right? But right now your ears just from hearing, not even balance, but hearing, they're a bit like, this is a very like unnatural environment. What's going on? And you can tell your body is a bit uncomfortable with this. There's a bit of pressure on you. Your neck gets a bit stiff, and then the most bizarre thing happened, which is why the guy was asking us to go in there by ourselves. Because now I wasn't necessarily, I said like, okay, sound's not going anywhere. And then I was just there, right, experiencing my body reacting to all silence. But it's a strange silence. It's silence. And then I could hear my heartbeat. Because your hearing starts to go inside.
Jesus.
Because there's nothing outside to hear. So I could hear my heartbeat. I was like, whoa. That's what a lot of people get anxious,
That
and
sounds
they
scary.
they go a bit panicky, because they think that it's hitting, it's beating hard or something, right? Because when do you hear your heartbeat? You don't, like,
Yeah.
just standing in the room. You don't, right? You feel it, but you don't hear it. And I started hearing the thumping. I was like, whoa, this is super trippy.
Does it have any like effects as soon as you like get out of it, like as you go back outside of the room?
Yeah, a lot of people.
Does it
were-
change?
Your hearing just kind of pops back open, and you can't be there for too long. That's all. It's like 4 or 5 minutes tops, man.
Right.
But a lot of people were sick that day.
Right.
They were like feeling really ill because they're
Jeez.
like because their bodies, like, we're so accustomed and wired to be in a certain environment. We are environmental creatures, and we adjust to the surroundings, and to, that's why we have these little like tingly sensations when things change. Because we're wired to detect those changes. When you put someone in a room where suddenly like you're effectively in vacuum, not air-wise but sound-wise, it is vacuum. Like, your body just goes like, what are you? Like, this is completely new. You can't just insert me here and not expect me to collapse.
Mm. I'm going to say ever since the day you were born, you've never not heard a sound unless you were deaf. But yeah, everybody's
Absolutely.
always hearing, even when you're asleep. You know, you still hear the cars going past, or
Yeah.
the heating in the house, or
There's
the wind
so many
outside,
more
or whatever
things
it
we
is.
don't know we're hearing. That's the interesting thing
Yeah.
about that experience. How it's so many, and we've all everyone's experienced the fact that at 11 in the night or midnight, if you're watching TV, you set it to volume 9 or 10, but at 9 o'clock in the morning you would never you literally can't hear the TV.
Mm.
What changed was the outside noise, like, right? That's the only thing
Yeah.
that changed. At midnight, it's quieter. At 9 o'clock in the morning, there's traffic. There's this. There's the other.
Yeah.
Right. So the same volume that suited you just fine at midnight, at 9 o'clock in the morning is completely unintelligible. You cannot hear a line from a movie or a show. That's what it is. This is the environment doing its thing. You go into a room where volume 1 would be deafening. Your brain, your body, everything just goes into shock. Like, what is going on here? Why so much stimuli coming from inside? Should be coming from the outside. So it was a super, 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 super interesting. I mean, I visited this place once, and yeah, I mean, 16 years ago, and it's still a very remarkable memory for me. Yeah.
Mm.
So there you go, guys. Lots of fun facts on sound and the physics of sound. I think we stayed on topic,
Yeah.
which for me is quite good. I didn't talk about the meaning of life and
Existential loss of hope that comes
and-
across you from handing over to an AI government and all that lot.
yeah,
that
and
usually comes
economics,
out.
exactly, and economics. Speaking of frequencies, did you know that? So I'm pretty happy about myself. And I'm most happy about the fact that next week I'll be seeing you all in person. So for those who are not coming in but having lessons this Saturday, not you yet, but I'll see Dan on Wednesday and of course everyone else on Thursday. For us to do our
You will.
first trial run in terms of recording something and creating a monitoring route as well.
Brilliant.
Any questions before I leave you, fellas?
Not from me.
All good?
No, not for me.
Not confusing? Was it too confusing today? Did I go too many places?
No, it was good.
All good?
No, it's good.
Okay. By the way, I don't take too personally if you tell me hey, stop with the tangents.
No, it's fine.
That's a lie.
Yeah.
I would take it very personally and I would immediately stop the call. They don't get me. I'm a genius. Okay.
Oh, dear.
34 past. Let's wrap it up. All right, guys. Have a good one. And I'll see you all when I see you all.
Okay.
Thank you.
There you
Take
go.
care, everyone.
Right,
Bye-bye.
see you
Yeah, that's it.
See ya. Bye.
Ciao.